Now that we've done some graphing and we actually got a really nice feel of what a relation and a function behaves like. So in chapter 7, let's begin it by officially defining what a relation is and what a function is. And then I'm going to try to approach it with just kind of non-mathematical examples and then slowly build to the math examples and get us there. So by definition, what a relation is, and my definition might be a little bit different than the book's. The book has a real technical one. I'm trying to be untechnical and try to get all the finer points. But a relation is basically a rule. All right, so there's some sort of machine, there's some sort of an equation, maybe it's a graph, maybe it's a schematic, maybe it's instructions that are verbally given, but there's some rule. And what that rule tells us is it takes an input value and it creates one or more outputs. So basically we have an input-output situation going on. And so you can really get a feel for like a machine, right? So the rules may be a machine. And then the input is maybe material, and then the output is we build a car, or we build a box, or we build a pizza, or something of that nature. So that's basically what a relation is. So just to kind of give you some examples, let me write down. So we got a rule, and every rule has something we input it, and something that we output. And so my first rule, just to get the idea down, is something like GCC. I'm going to say GCC is a rule. GCC is a relation. Because what it does is it takes input. This input, depending on how we define it, can be a lot of different things. Usually when I'm in a face-to-face classroom, I get a lot of suggestions. But usually everybody can agree that the input for GCC is a student. So you are an input for GCC. So what happens? Well, we put you in GCC, right? They make you pay tuition. They make you sit through classes. And then the output is varied. Some of you might have some transfer credits. Some of you might have some certification done. Maybe you learned how to speak Spanish or play the guitar. Maybe you earned your AA degree, right? So it's very varied. So again, the idea is that for any one student, the rule, the relation GCC creates one or more outputs. So maybe for one of you, the only thing you got out of GCC was an AA degree. Maybe for some of you got an AA and some certification. Maybe for some of else you got an AA, a certification, and transfer credits to go to ASU or NAU or the U of A. So that idea that one or more outputs are created by some sort of an input. And notice that you are unique, right? So for one student, the output might be a little bit the same or a little bit different for another student. Another classic situation that I think is a nice idea of an input-output system is a gumball machine. All right, so perhaps you haven't been around one in a while, but the gumball machine, basically what we do is we put money in the gumball machine. Right, and then what it does is we spin the little dial, we make the machine work, and out pops out some gumballs. Okay, and then depending on how the gumball machine is oriented, maybe just one gumball, maybe you get several different pieces of gumball, maybe you get a toy. So again, the idea is we have an input-output system. The gumball machine itself is the rule. It takes some money. You spin the dial and out pops up something, right? Again, a gumball, maybe a toy, whatever the case might be. So classic input-output system. Starting to get a little bit more mathematical. Perhaps you guys are working for a company that pays you $12 an hour. So how do they calculate your pay? Well, they'll use an equation. Let's assume no taxes at the moment, right? So your pay rate will be $12 times the hours that you work. So P being the pay rate, the pay you get, and H being the hours that you work. So my relation, my rule, is now an equation, the very thing that we're trying to solve. What goes in? Well, we put in hours, right? So you put in 0 hours, you get no pay. You put in 20 hours, right? We can work that calculation out. And then what you end up getting out, the output is actually a dollar amount. So hours in, they put it in that formula, and dollars out. Of course, what complicates this a little further is the fact that they take taxes out. But let's just try to keep it simple just to get the idea of what a relation is. An input-output system, right? Some rule that takes an input and creates an output. We've also seen that when we have an equation, we can actually create a table of data. So we've been doing that really hard And so, maybe we're working on a function or a relation, that does something like that, right? And so my inputs are basically my x values, as we've seen, and my outputs are basically my y values that we get. So this particular relation, this input-output system, has these 5 pieces of data that work as input and these 5 pieces that work as output. And again, we could probably construct an equation that actually tells us exactly how -2 turns into 5 and -1 turns into 8. But that is technically a rule. And then, of course, we also have graphs, right? So my rule could basically be some sort of a graph. So there's an absolute value graph. And so, again, in this case, the input would still be an x value, right? So you tell me where you're at on the x-axis, and then I can figure out where you're at on the y-axis. So, again, visually, we're seeing what's happening in this equation. We're seeing what's happening in this table. And in this case, we have a absolute value graph. So there you have it. A relation is basically a rule. It's some concept like a GCC. It's a machine like a gumball machine. It's an equation. It could be a table. It could be a graph. It could be a lot of different things depending on what we want to do to define our situation. Every rule has a set of inputs and every rule has a set of outputs. And what the rule does is for every input, it creates one or more outputs. Classic relation. So building onto that, we have this concept called a function. A very important idea in mathematics. Now what a function is, the first thing I have to tell you, a function is a relation. So what I'm basically telling you, it does this. It's a rule that takes an input and creates one or more outputs. However, what makes a function very unique, and not like any other relation, it's a relation that takes an input value and only creates one output. And key in that. So basically what I like to say to really nail it down, one input creates one output. So a relation in general, you can have one or more things coming out, but a function is very, very specific. You put one thing in, you're going to get one exact thing out. One thing in, one thing out. So if I had to paraphrase the definition for a function in just one simple statement, that's it. One thing in, one thing out. So we have over here 5 different relationships, right? GCC is a relationship, the gumball is a relationship, the price, the per hours, your pay rate, this table, and this graph. These are all relationships. But are these relationships functional is the next question. And what we basically do is just figure out, do I have one thing in, do I have one thing out? So I would say the GCC function, this is not a function. It's a relation, but it doesn't behave functionally because some students will have more than one output. So there's not one student in, one student out. Some students could, right? Like I said, there's some of you who just come here and get a certification, but there's other students, right? One thing in, one thing out, that doesn't work because they'll get multiple outputs. The gumball machine, this is kind of a tough one. I'm going to actually say that this is not a function. Although I do agree with the fact that some gumball machines do behave functionally. You put something in, right, you get one gumball or one toy out. But so it kind of depends on the orientation of the gumball machine. So just in general, how about we say it's not a function? Because there's a lot of gumball machines, you know, where you put your money in and you get a lot of those little gumballs. The hourly pay, I believe this is functional. Right? We actually hope it's functional, right? Because if I put 12 hours in, 12 times 12 is 144. So one value of hours coming in and one value coming out. So definitely this is a functional situation. You change your hours, like if I do 10 hours, 12 times 10 is 120. So very, very functional in this case. For this table, again, all we're looking for is, does this input of -2, how many outputs does it have associated to it? And I don't see -2 going anywhere else. So -2 in, one y value out. -1 in, one y value out. A 0 goes in, a 9 comes out, and that's it. A 1 goes in, a 10 comes out. A 2 goes in, an 11 goes out. So this is very, very much behaving like a functional situation. because one x, one input, creates one y, one output. So that's also a function. And then last but not least, is this a function relationship? Some of you have probably famously heard the vertical line test. And that vertical line test is a visual way of just saying, for that x value right there, right, for that one input, how many y values are associated with it? Well, I only see one. All right, and then there's actually a repeat over here. That's why you guys shouldn't think of repetition. But this x value also has the same y value, but that's okay, right? 1x in, 1y out. And it very famously passes what we call the vertical line test. Every vertical line crosses that graph exactly once, which basically tells us that 1x creates 1y. So this is a function. So we'll play this game a little bit more in some future videos. Why don't I cut this one off? We're about almost 11 minutes long. But hopefully that gives you a good idea of what a relation is, an input-output system where one thing in, one or more out, and then a function being a very specific case of a relation where one thing in, one thing out. So all functions are relations, but not all relations are functions. All right? So functions are very special. See you guys in the next video.